Hello everyone, I hope you're all doing good. So this tutorial is about human detection inside the Vision framework using SwiftUI. So I'm going to basically show you first how to detect humans and count them in images, and then I'm going to show you how to basically set up a camera feed and count humans using that feed. So let's get started. So first of all, in content view, I'm creating a function count people, which is basically creating an image from the image name inside the variable image. After that, it is going to convert it into CI image, and then a request is created with the function vn detect human rectangles request, and then observation variable is created with the results of that request converted into vn human observation. After that, I am creating a vstack which will contain a toggle as well as a text to display the actual count of people inside an image, and the toggle will on the change of the toggle, the count people function will be called. Also, this function will be called when all of this view appears for the first time. So here I have created two variables inside the content view, people count, which is going to basically count the number of people and display it on the screen. And another one is basically detected rectangles, which is basically CG-rect, an array of CG-rect, which will be drawn on the top of the detected people inside the image. After that, I am setting both of the value of these variables using the observation variable. Again, I am going to basically set the target environment as simulator and make the request to only use the CPU, because if I'm not going to set this if statement, it is going to give me an error, because Vision Framework is basically designed in a way that when it's run on the device, it uses both GPU and CPU, but in simulator we do not have that capacity to make this parallel execution. So for that, when it tries to basically access the GPU, it is going to give you an error. To avoid that error, we are going to force the request to use only the CPU in case of a simulator, but in normal device it is going to ignore this if statement and will directly run on the default settings of the device. After that, I have created a variable detect whole body, and I am setting a certain attribute of the request variable. This is basically just to enable or disable the full body detection. So if you do not want a full body to be detected, but the minimal thing to detect a human is just its upper body is detected. So if you want that functionality, you are going to basically set request dot upper body only to true. It is going to basically increase the number of detections, but if you want a very precise detections and only a full body detection, you are going to set it to false. After that, I'm creating a handler variable which is going to basically get the CI image that we have created from image and pass it to an image request handler, and then it is going to perform the request that we have already created. Here I'm showing you the three images that I'm going to use in my testing of this human detection inside images. I'm going to paste their link inside the description box. So now I'm creating the view inside the content view. It is basically a Z stack containing an image and then an overlay of the detected rectangles. You have seen that I have used a scale factor. This is basically to adjust the position of that rectangle in the Y scale. Otherwise, it is quite at an offset from the original location of a person. And after that, I have added a stroke color to it. After that, I am creating a VStack which will contain a toggle as well as a text to display the actual count of people inside an image. And the toggle will, on the change of the toggle, the count people function will be called. Also, this function will be called when all of this view appears for the first time. So when I tried playing the code, it has given me an error that you can see on basically my right bottom side. It is basically creating an error in the geometry reader. So I have added this ID inside the iterator of detected rectangles. The count is shown, but the detected rectangles are not shown due to this very reason. So we are going to edit this code and play it again. So now I have played the code. You can see that it is going to show the upper body at first, and when I'm going to enable the toggle, it is going to show the complete body. And I'm going to basically try it for all the 3 images inside my assets folder. So this is the image number 2. It is showing the upper body, and now this is the whole body. But since the people are not present with a complete view of their bodies, so it is going to just display the upper body. And here you can see that in image number 3 it is displaying a complete body of the like adult, but the child is not taken into account. This is due to some shadows in the background. So the contrast against the background also matters a lot in terms of any sort of detection, especially in human detection for this model as well. So I am here creating another view with the name of human detection in camera feed, which is basically going to handle the view of camera, a live camera, and after that it is going to display all the rectangles on top of it. So I have created a separate view from it, and I'm going to call it inside the content view when we are going to process the video. So here I have created a struct with the name of video preview view. It is going to basically override two of the functions, make UI view and update UI view. In make UI view, you have seen that I have created a preview layer with AV capture video preview layer function, and I've passed my camera session to it, and it has added all the relevant properties like video gravity, and added it to basically as a sub layer to my main view layer. And after that, it is going to basically set in update UI view, it is going to basically set the bounds of that view. So this is all for the setting of the preview layer. Here I'm creating another class inside my project with the name of capture delegate, which is going to basically override a capture output function to handle the output of the camera. And it has extended ns object AV capture video data output sample buffer delegate and observable object, because I'm going to get two values from this class, and I'm going to display it inside my newly created view, which is people count and detected rectangles. So here I'm fixing the errors by adding the relevant imports. So just like passing the image to basically my VN detect human rectangles request function, I am passing here the buffer after reading the output from it. So basically I have created a pixel buffer here and I am passing it to my VN image request handler, and rest of the code is pretty much the same that I've used for the image. Here I'm setting the relevant variables inside the human detection in camera feed view. So basically I have created a capture session queue with a certain label, and then an observed object which is going to basically help us get the values from the capture delegate class. So you have seen that in the setup camera session, I have created a video device, after that a video device input, and then video output, and kept set all of these basically variables inside the capture session with the inputs and outputs. And after that I have committed this configuration, and then I have basically started the session with the capture session variable that I have created earlier. So here I am creating the actual view inside the human detection in CameraFeed view. So I have created a Z stack that will contain my video preview view with the session of capture session variable and then an overlay just like that in the image. So here I have created a text and with the label of human count and set a different properties, and on appearance of that text it is going to basically start running the session, and when this view disappears it is going to basically stop running the session. So this is all for basically my human detection in camera feed view. So here I have just used another bool variable to basically use the image or camera feed. So I have created a variable with the name of his camera feed, and if it's false we are going to display the normal image processing, and if it's not we are going to load another view which is basically our new view that we have created for video processing. So here I'm running the code again, and as you can see that when it's set to false we have basically watched the view that we have previously seen, and if it's set to true basically the screen goes empty inside the simulator because we need an actual device to view the camera feed and all the processing on it. We cannot run it on a simulator. So let's move to the device output. So when I played it on the device, there is a certain problem. Basically the XY and width height were all inverted, so I have simply inverted the values of it. This is basically due to the orientation of camera. So you can either adjust it when getting these values of CGRect from the request inside the functions, but I'm modifying it inside the view here. So basically you just have to keep the values parameter same, but you just have to switch their values. So y values goes to x and x values goes to y. So this is all the change we need to make before running the code again. Also, do not forget to add the relevant permissions before running the code on your actual device, because it will be needing the permissions to access the camera. So here I've used some of the video from pixels to display you the results. So basically you can see that when they are moving, in the first video a good number of people are being detected. In the second video, since the everyone is very close, so very few individuals are detected. In the next video, basically everyone is moving very fast, and as you can see that the detection rate is good considering the speed. Now I'm going to show you another video. So this is basically people moving in a shopping area. They are moving quite slow, but the angle is such that it is difficult to detect people that are far away. The people who are passing nearby, they can easily be detected. You can get all of these videos on a link I'm going to share in the description box. So you can see that I'm going to basically now move to another video. This is basically just like a CCTV footage of a public place. You can see that there are some false positives, but people are generally detected. So basically seems like the detection ratio is greater than 60%. So now I'm going to basically move to another video. Here the view is quite blurry, and this is an interesting case because the faces and the overall view is not that clear, but still the detection ratio is good considering it's not clear. So it means that the algorithm is good enough to basically detect the humans in case of blurriness of the camera, or if the camera is shaky. So guys, this is all for this video. I have put in a lot of effort to create this video so that it is easier for you to check it on the live camera feed as well as on the images. You can basically test it in a real environment as well. I just wanted to basically test it on different data set which we cannot do with a simple camera. So I have used these videos as basically a feed to my camera. So I hope you have enjoyed this video. Do not forget to subscribe to my channel and like and share this video with your friends. This is all for this video. If you want any further addition to this basically tutorial, you can ask me inside the comment section. I'll be waiting for your feedback. Take care of yourself. Thank you for watching.